Look around you. Everything you see, from the device in your hand to the skyline outside your window, owes its existence to one material. Steel. It's the skeleton of our civilization. The silent giant holding up our world. Before skyscrapers, before machines. We needed a material that was strong, flexible, and abundant. For centuries, humanity struggled to create it. The story of steel is the story of us, of curiosity, fire, and the drive to build. Iron atoms forged in ancient stars, they lay hidden in Earth's crust, until we learned to harness fire, and transform them from a rusty rock to a gleaming girder. Steel's journey is one of science and ambition. It's a tale of how we took the raw stuff of the cosmos and built a new world. One furnace, one idea at a time. Steel is more than a material. It's the foundation of our dreams. Every bridge, building, and railway is a monument to this transformation. The quest for better materials is the quest for a better future. Steel's story began with embers and led us to the stars. This is how we forged the backbone of our world. For most of history, iron ruled. It built the first great machines, bridges and rails of the industrial age. But iron was heavy, brittle, and prone to cracking under stress. Bridges collapsed, rails snapped, and machines broke down. Iron was hard-won, forged in fire and sweat. Ancient furnaces called bloomeries produced a spongy mass of iron and slag, hammered for hours to make wrought iron. The iron rails of early trains bent and broke, making travel dangerous and unreliable. Locomotives derailed, and bridges sometimes failed without warning. Steel, iron's stronger cousin, required just the right touch of carbon, a delicate, expensive art. The crucible method made tiny batches, reserved for swords and tools of the elite. Steel was rare, precious, and progress was limited by its scarcity. Before steel and reliable railroads, travel was slow and exhausting. People journeyed by horse-drawn carriage over muddy, rutted roads or by riverboat when possible. Journeys that now take hours once took days or even weeks. The world felt vast, and progress moved at a crawl. You couldn't build railroads or bridges with something as costly as silver. The world needed a breakthrough, a way to make strong steel, cheaply and in bulk. Blacksmiths toiled, muscles straining, forging every piece by hand. The first industrial revolution ran on iron, but it was brittle and unreliable. The dreams of engineers were held back by the limits of their materials. The world was ready for change. A new era was waiting to be forged. The stage was set for a revolution in metal. Enter Henry Bessemer, a restless inventor with a passion for solving problems. But before Bessemer, steel was a rare marvel. What made it special? Steel is an alloy, mostly iron but with a precise touch of carbon. Too little carbon and iron is soft and bendable. Too much and it becomes brittle, like cast iron, which shatters under stress. The secret to strong, flexible steel is carbon content, ideally between 0.2% and 2.1%. But for centuries, controlling this was guesswork. During the Crimean War, Bessemer's new artillery shells demanded stronger cannons. Iron just couldn't handle it. Bessemer experimented tirelessly, searching for a breakthrough. One day, as air blasted through molten pig iron in his converter, Bessemer saw something remarkable. The iron burned hotter, and impurities including excess carbon were removed. For the first time, steelmakers could precisely control the carbon content, transforming brittle iron into strong, reliable steel. Bessemer's process revolutionized steelmaking, turning an art into a science. In the Bessemer converter, tons of molten iron met a blast of air, and in a fiery spectacle, impurities vanished. Pure steel poured out in just 20 minutes, fast, cheap, and consistent. Where old methods made pounds, Bessemer's process made tons. He unlocked the age of mass-produced steel, changing the world forever. The material world would never be the same. One idea, one spark, and the future was forged. The age of steel had begun. Bessemer patented his process in 1856, but early results were mixed. Phosphorus in some iron ores made steel brittle, but innovators like Robert Mouchet refined the method. By the 1860s, the process was perfected and spread rapidly. Steel production soared, from 70,000 tons a year to over 1.3 million by 1880. Prices plummeted, making steel affordable for all. Railroads were transformed. Steel rails lasted decades, enabling safer, faster, and cheaper travel. Steel became the backbone of a new global economy, connecting cities and continents. The Bessemer process ignited the second industrial revolution. Skyscrapers, bridges, and machines rose on this new foundation. The world felt smaller, more connected, and full of possibility. The roar of the converter was the sound of the future. Steel was no longer a luxury. It was the material of progress. The first industrial revolution ran on steam coal and iron, powerful, but limited. Machines were clunky, buildings short, and railways fragile. The second industrial revolution, starting around 1870, was built on steel, electricity, and chemicals. Steel made everything possible: taller buildings, stronger bridges, faster trains. The Brooklyn Bridge and Eiffel Tower soared thanks to steel. Ocean liners and global rail networks reshaped commerce and travel. This era was more scientific, driven by chemistry and physics. The Bessemer process was a triumph of industrial chemistry. New inventions, engines, telephones, light bulbs relied on steel infrastructure. Steel factories, power plants, and towers became the stage for modern life. The world was transformed, and steel was at its core. The material revolution had changed everything. The rise of steel coincided with sweeping political and social change. New empires like Germany challenged Britain's industrial dominance. Steel fueled imperial expansion. Ships, railways, and telegraphs reshaped continents. National power was measured in steel output and military might. Battleships like HMS Dreadnought redefined warfare. Steel mills drew millions to cities, creating new social classes and movements. Labor unions, suffragettes, and political upheaval marked the era. Prosperity and tension grew side by side. The same steel that built cities also forged weapons. The world was being rebuilt, literally and figuratively. Steel was both a symbol of progress and a tool of conflict. Steel changed the face of our cities. In the late 1800s, Chicago built the world's first skyscraper, just 10 stories but a revolution in height. By 1931, New York's Empire State Building soared to 102 stories, made possible by over 60,000 tons of steel. London's bridges, Sydney's Harbor Bridge, and San Francisco's Golden Gate, each a triumph of steel engineering. By 1900, the world produced over 28 million tons of steel a year, fueling more than 200,000 miles of railway. Steel made cities grow upward and outward. Skyscraper booms transformed skylines from Chicago to Shanghai. Factories, bridges, and homes, steel became the backbone of daily life. From railways to kitchen appliances. In the 20th century, steel production powered economic growth, lifting millions out of poverty and connecting continents. Today, over 1.8 billion tons of steel are produced each year, shaping everything from cars to skyscrapers to surgical tools. The story of steel is the story of progress, of bridges built, cities risen, and lives transformed. As we look ahead, steel remains at the heart of innovation, supporting new ideas, new industries, and new dreams. The science of materials continues to drive us forward, building a world of endless possibility. Through every era, steel endures, quietly supporting our world, a testament to human ingenuity and ambition. The backbone of our world is forged, not just in fire, but in vision. And the story continues, with steel and with us.